So basically, the vector functions, this will be our basis for the chapter 14 and 15. So we are going to see the functions. First, the function should be in terms of multivariable. So we can have xy or xyz in three-dimension system. And from this overview, what we can do about the vectors is actually, vectors is like a space, okay? It's like space. So if we have done previously in calculus 1, all the calculus techniques like derivatives, integrals, basically we could do the same thing, okay, with some proving here that I have put into the video, that basically we can take the limit for the vector, which is going to be limit for every component. And as a consequences, we are going to have the derivative as well, that we can take that into our definition as well. Okay, so basically that's the conclusions. Not truly that complex conclusion, but this is just to say that you can treat factors like you treat the normal functions, like a normal function. The difference is the factors will be having three components x, y, z. Okay? And basically it will be also the same with the integrals, but the I think the unique one will be the arc length, because the arc length from the parametric going forward to the factor functions, we can make the formula for the arc length becomes the magnitude vectors, the magnitude value of the vectors of the r prime. Okay, so that's the arc length. And basically, another thing on the vector function is about the curvature, is how smooth the curve will be. This I'm not elaborating as much as the other thing. I just want to know what the curvature means. Like for example, if I have something like this, we say this is quite rough. Smooth means something like this. The changes is not rapidly increasing or decreasing. It is going to be steady and you can say quite slow. But here, suddenly change, the spike changes. Okay? Going up and then suddenly going down. We say it's not too smooth or it's quite rough. Okay? And how much rough and how much smooth is based on the some numbers. Which one is bigger? That we can do some calculation. We call it curvature. And what about this? I think you could take that as an overview. I have made the video, so we could just rewatch that. Okay, so basically this is what I have trying to put in the system. And let me go forward for the chapter 14, which is the partial derivatives. So we start with the very introductory. We can start from the function of two variables, which could be understood as pair xy. So we could think this xy will be paired as a variable. Usually in calculus 1, we have the x as a variable and then y is our function. But now the function will be made up by two variables that are both of them independent variables. Okay. So what does that mean? It means that whenever we put the number x and y, we are going to get another value, right? Another value that, to make it simple, let's say the value will be z. Okay? Because this is, I think, makes sense because we have three axes, x, y, z. Whenever we put x, y in this surface, so x here and y here, and it got some point here, and then we could know from the function that it makes, we could know the value, which one is the height, which one is the level, and we could get it into these axes, and we get the overall values, right? So basically, we can say that based on the domain and range, if you see this particular definitions, then we can take the domain D, set of D of F, okay, and its range is the set of values that F can base on. That is this range here. Okay, this is basically this normal, very normal definition, and it could be understood very well from this picture. Okay? Because we can set any number in between this xy plane to get our z, okay, that is fxy. And then this is also another definition that is quite, I think, quite simple here. Just to say that this D can be understood as a projections of this surface that we want. The surface is basically our function. Like before this slide, I show you some of the example that might comes up as our surfaces in quadratic surface especially. So perhaps this is our surface, then our variables will be here. We can determine, and then we can find each point that is going to be matched with each one of the height or level in S. So that is a function of two variables that we are expecting to have in this chapter. And application-wise, if you see map, like in geography or any world map that you have, sometimes you have something like this that will distinguish the level. Okay? Which one is the highest one, and then it will maybe gradually decrease it, and you could see the differences. Okay? So this is, I think, applications for level. We say this is a contour. Okay, the contour. Usually we take this in application for mapping. It could be also about different temperature. Maybe one area is like now, maybe we are in the rainy area, and maybe if we go south, maybe dry, no rain, right? Or maybe the temperature, which one is the hotter? I think in the government website for climate and weather, you can see different color as well, right? So this is also can be done, and it's actually we can simulate those surface like in functions. Maybe functions on temperature, function on different level of contour of maps. Okay. So this is just introductory. Don't worry about all of the small things. It's also, this is also can be true for if you have function of 3 variables. Okay? So far this is 2 variables, but it will be also worked with x, y, z, for example. Okay? Which means that we are going to have 3 independent variables, x, y, z. Okay, now let's move to the calculus part. So this is just an introductory for the function. So let's move to limit and continuity for a partial derivatives. Okay. Now, suppose that we have 2 functions. Okay? Suppose we have 2 functions. Okay? This function f and function g. Okay, you can see the details. And suppose that this f, or maybe let me write here. Suppose that suppose that x and y both approach 0. Or you can say the point xy approaches the origin. Now, if we take the approximations, okay, which means we are going to take values in maybe nearby 0, this is what we could get. Okay. This is for, or let me write this a little bit down here to make it clear. And okay. Now we have two tables here, table 1 and table 2. So table 1 is all variations of x, y for function f. Table 2 is for function g. Okay, now what I want you to do is we need to focus on the number that is going to be the final result. Okay? So the goal is this x and y, we're going to approach to 0. So 0 is here. Okay? So we can start by taking from the left here, from the right, or from the top, from the bottom, and we can see and match the numbers. Okay? And match the numbers. When we start from the very far left, we see the 0.455, and then the very far right, also the same. If we go here, we see that it's going to be, as we approach 0, it's increasing, right? It's increasing. And maybe if we take another step nearby the 0, maybe focus on these 3 rows here and 3 columns here. We see that it's about, especially the point here in the middle, we see that this is going to be 0.999, 0.999, 1, 1, 1, 1, 0.999, 0.999. And of course, if we take here, it will be not defined, right, from the limit itself. But for the nearby 0, we see that the value seems to be closer to 1. Okay, seems to be closer to 1. With the same idea for this function g, you see that it is not as consistent as f. See that here 0, 1, 0, 1, and negative 1, negative 1, 0, 1, 0. Okay? And you see that this is negative 0.7 and then 0, negative 1. It's also not really consistent, and it's not getting anywhere. It's not closer to any number or any values. Okay? So let me write here that it is going to be not going to be closer to a finite value. And the left, let me write just to notes that it seems closer to a finite value, which is 1. Okay. And suppose that we write this in terms of a limit. Okay. And let me just write this first to make the definitions for the next part. Okay. So let me write the limit as x, y approaches 0, 0, sine x squared plus y squared over x squared plus y squared. This will be equal to 1. And here, since we get the inconsistent value, this will be doesn't exist. Okay. And in general, we use the notations of limit So this is indicating that the values of f, this will be approach the number L as the point xy approaching the point AB. Of course, we need to have in all in the same domain F, okay? So this is also true if we try to make to write in a more precise definition using the epsilon delta definitions. But now we are including y. Okay, we are including y. So we can make the values of f as close to L as we like by taking the point xy sufficiently close to the point AB, but not equal AB. Because if you take equal, that's not limit, right? It's the value of the functions. So that's why the limit should be understood as the point or the value nearby our the point that we observe. Okay. So by definitions, we could also write something like this. So we say the limit of f as xy approaches the point AB, this will be equal to L, and for every epsilon that is going to be positive epsilon, which means it's going to be the distance, okay, this distance, the point, there will be a number that we call the delta. Basically, this is the same idea in calculus 1, but we input the other variable y. So we need to have the delta now. It could be understood as the distance using Pythagorean theorem. Okay, so if you understand the x, y, it makes a triangle, right? So the delta is this hypotenuse. Okay. And basically delta and epsilon is just the we say it's just to show that there will be some numbers that we need to make sure that this limit is in its domain. It will be defined, okay, and it will be equal to L as long as we could find some delta that will satisfy some epsilon. Okay. This is the epsilon delta definition in calculus and in calculus 1, and we take this definition in two variables. Okay, in two variables. So we could understood this by taking this into this definition. Now we see the delta here, like I mentioned. This could be understood as the Pythagorean. I think it could be connecting the x and y easily. So every point we take within this range of delta, within this delta here, that is, we understood the deltas will be very small. This will result in terms of this interval. And we say we have interval L minus epsilon and then the L plus epsilon. Okay, and whenever we have in between this, using this point here, as long as that is true, then we are going to be confirming that there is a limit. Okay, there is a limit. Now the interesting on this limit is how to show the limit doesn't exist, because if you remember in the calculus 1, we usually have the conditions where it will be undefined or indeterminate, like 0 over 0 or infinite over infinite and other indeterminate forms. But now, since it is function of two variables, now it is more complicated to imagine and to visualize or to compute as well. So let me go through the next page. Okay. So this I forgot to write here. Let me give the titles. Showing the limit does not exist. So if we remember, maybe this is distracting. Maybe let me put on the other side first. If we remember in calculus 1, that if we have, let's say, maybe some hole here, if we say this limit exists, for example, value L, okay, this is A, and this is f of x, we say that we need to prove limit as x approaching A from the left, right? F of x is equal, if there is a limit, right? If there is a limit, need to be equal with the limit to the right, okay? And this will be equal to L, right? But when it is not equal, then limit doesn't exist, right? Okay. So we only have two options, right? Left, right, left, right. But now we have 3 dimensions. So we have a space, right? We have a space. Okay. So for 2 variables, let me write here. For 2 variables, so this is for single variable. So for 2 variables, we can let the xy, let me use different color, the xy, the point xy can be approached, okay, can be approached, or approaching the point AB from many possibility, or from an infinite number of directions. Okay, so in 2 variables we only have directions left, right, but now we have 3 dimensions. We can basically say we can approach the point from any directions, okay? From any directions. So what should we do? Then we need to make a reference, okay? We need to make a reference. So let me write here, one way to solve or to show that limit xy ab f, or maybe limit f x y does not exist is to find different paths, okay, different paths. Different paths of approach along which function has different limits. Okay. Now, what does that mean? Okay, let me go through the example. Okay. So if we see this picture here, okay, consider this picture as a XY plane in the 3D system. Okay. So suppose that this is 3D system, but we only see it from XY plane. So when we approach this AB, we can approach from here, we can approach from here, we can approach anywhere, right? It is not the same with the calculus one when we have on the left, right, and then we need to make sure that they are equal, or we have the value and the limit exists. But now we have from everywhere. Now what can we do? What we can do is basically we need to choose the path. Okay, choose the path. So what is the path? The path means any equations that usually quite simple that we can substitute between x and y. It could be line equations, like maybe y equal x, that we can substitute x and y, that we can basically evaluate the limit, and then whenever we find that the value is different, so we need to take like several paths. Maybe y equals some constant, like line equation, and maybe y equals 0, easy to follow, or y equal 1, and then maybe y equal x, or maybe y equal x squared, it can be also. Whenever we find that between those lists we have different value, then limit doesn't exist. But if all of them are consistent, the same value, we say limit exists. Okay. So we can have, I think maybe some example. I think I haven't put the example here. Okay, let me just go through example. This is for a later part. Okay. So this is the definition. Okay. So if the fxy is going to be approaching some value L1 as xy approaching AB along a path. Okay, so a path is something that we design. Okay, we check, we confirm. Okay, so we check the path C1. Okay, we check the path C1, and then in another conditions, the f will be closer to L2 along another path C2. Okay, and when the value is different, L1 is not equal L2, then this will be not existing. The limit is not exist. So if we take the limit, let me start with the previous example. This is 0, 0. So x squared minus y squared over x squared plus y squared. So how to make this, how to confirm? Okay, now we need to make the path. Okay, we need to design or list any path that is possible and perhaps easily to compute. Okay, so we can set the procedure that first is choosing a path, not one path, but maybe several paths. Maybe let me choosing several paths. For example, we can choose y equals 0, so that we are going to have so when y equals 0, it means the point of xy approaching 0, 0 through x-axis, right? Which means the function becomes fx0 because we make the y as a constant 0, okay? Which means this is going to be x squared over x squared, which is equal 1 for all x not equal 0, okay? Because 0 is the one that we need to approach, right? So we say from this y equals 0 that the fxy, this will be closer to 1, or we are getting to approaching 1 as xy approaching 0, 0 along x-axis. So basically we are going to check whether it will be a consistent value or not. So that we need to make a list of some paths that possible. And basically the more you see the type of the functions, you will know which path that you need to try. Okay? And then choosing another path. Maybe first it's not choosing several paths. Maybe choosing one path first. And second, choosing another path. Now, we can also choose x equals 0, which gives you the point will be approached through the y-axis, right? Which means that we are going to take x as a constant 0, okay? And then this will be equal to this, which is -1, which you can see for all y is not equal to 0. So basically, we say that the fxy, it will be closer to -1 as we approach the point through the second path, which is the y-axis. Now, from this two different value, we can make a short conclusion that this will be non-existent. Okay. So we can conclude, since f has two different limits as xy approaching 0, 0 along two different paths, the limit of fxy does not exist. Okay, of course, we are only using two paths, but sometimes maybe we need to try 3, 4, 5. But basically, how to choose the path is basically up to you. Any equation could be possible. But my suggestion is you could check the equation first. Can the equation be solved if we try some combinations? maybe some quadratic formula or maybe parabola, maybe cube, or even perhaps just a line equation is enough, sufficient. Then we could check, and then whenever we can solve and then find the value, maybe it will be much easier. For some equation that is not easy, maybe it's not a good choices to compare with. So we think maybe some other that is easily to be algebraically solved within the limit.
How? I think it's only two possible ways paths we can choose.
Mm.
Right? I mean, if we take y equal to 0 and x equal to 0, and what can you suggest else? I mean, which ways I can find here else?
It can be y equal x, it can be y equal x squared, or x equal y squared. It could be any equation because it's a space, right? And basically, because in the plane we can like using any single variable equations, that is either x is function of y or y is a function of x. That is possible because
So I need to find the limit x. It's the coordinate 0, 0.
yes.
So I mean, what is the reason to find the limit if my y equal to x squared or x equal to y squared?
Well,
How to find the reasonable coordinates, reasonable x?
well, it's actually it's a good question because basically for every function of two variables, since there are many ways, like many variations that we can take as a path, right? Infinite number of paths.
Yeah,
So
but for the finding this area, I need to find. I mean, for finding possible reasonable or equations,
Yes.
passes, I need to find. I guess I need to find the area around this coordinates.
well, the area could be as long as they are in well, we assume that they are in the same system, and then since I think better to think this like this is a plane, and then maybe this is a surface that is going to be take place. Let's say suppose that this is the surface. So we can draw any equation, right? As long as we set up the same domain and range, right? So basically there is no like I would say infinite number of paths. So the only way we can think is through by looking at these equations. Can we do something on these equations? Can we think maybe different equations? Maybe if we substitute different y and x, maybe you can solve algebraically and then maybe you can give some value at some point. So this is not about proving the limit exists. This is proving limit is not exist. So we need to find whether they have different values. So there is an infinite number. Okay. Okay, let's take a break for a while. And I think I will continue later for practice, okay? Practice for midterm. Year or last 2 years. But they are include the quadratic surface here, so you could just pass it. Or if you want to, you can check the video first, take some review, and you can check the quadratic surface here. But what we are going to have as a midterm is basically chapter 10, 11. Okay, so basically the parametric, the polar, and the series, okay, the series until the Taylor-Maclaurin series. Okay.
Including.
Yeah, Taylor-Maclaurin. Okay. And the midterm will be more heavy on the chapter 11. Okay. Maybe 40-60%. 40 chapter 10, 60, chapter 11. I haven't yet decided how much questions it should be. Maybe only 6 or maybe 6 with some branches, with some question. Each question has another question. So I think let's start this review. Do you want to start with chapter 10 or 11 with these questions? Chapter 10 or chapter 10? Which one? Number 1, number 2, number 3, or number 4? You go from 1? Okay, I think number 1, if we start here, do you want to try first? I think it's quite simple. It's quite simple. Yeah. You want? Okay.
I don't remember.
I think it's enough if you just write the formulation. And then you want to copy it with the calculator, it's okay. And the important. The area is here. This one.
I don't remember, but maybe.
Oh, it's square.
Square, yes, square.
The area.
Square. Don't you remember the formula for the gradient of powers? Right? So? Yeah, nice. Okay, thank you very much.
I think
It should be costly.
Huh?
I don't think it's 2. It's cos 2 theta. Cosine 2 theta.
Right.
And not 2. You're supposed to.
Just cosine.
Yeah, that's okay.
Oh, yeah. Ебанешься.
Yeah, I think it's okay. It's just a weird and mostly correct. The rest is, I mean, you haven't finished yet, but I think this is okay. Okay, I think as mentioned there, so this could be understood by this is theta 0, pi over 2, pi, 3 over 2 pi, right? So this will be the area is half from pi over 2 to pi. And then this is going to be the 2 plus cosine theta squared d theta. Okay. And then the rest is just finishing off the yeah. Correct. Okay, I think this is quite a straightforward question. Okay. So I think quite straightforward question. As long as we can define the theta, and then we already have the equation here, and the rest is just a normal computation in integral. I'm suggesting to use your algebra first, okay? And then you can use calculators maybe at the last 2 lines, okay? Just to help you avoid mistake when you input into calculators. If you input the numbers as early as possible, usually you are getting maybe different results because of the algorithm in your calculators maybe have some differences because of the operating system maybe different. So I think it's better to take some lines first, make it a little bit okay for you to check, and then you can input into calculator. Maybe it's just my suggestions. Okay. So what next? Which one you need to solve? Number 4? Number 4, is that okay? Yeah, number 4 is the, yeah, this is a little bit, it's actually easy but tricky. Okay? Easy but tricky. So first is you need to understand what is the arc line. So arc line means if we have the polar, suppose the polar is something like this, which I didn't give you the picture. So this means for this question only, I expect you know how to draw. Okay. So remember, if we have this, which is if we take the another formula will be 2 plus 2 cosine theta, right? or if we just take the inside equations, which is only 1 plus cosine theta, we know that since this is 1, 1, and we already have some preview on the polar curves, this will be cardioid. If you remember, the cardioid, something like the shape is similar to the heart, right? The cardio. And then since this is cosine and it's plus, this will have a large portion on the right side. Okay, so we can imagine the picture or the figure for number 4. Let me make into the other picture here. So let me write the equations. R equal to 1 plus cosine theta. Okay. So this will be my sketch. No need to draw like really exact or proportional. As long as we can see the cardioid, I think should be okay. Now we need to find the basically the measurement from this point here, from the theta 0, and then measure until back into the theta 2 pi, right? 0 to 2 pi. But this is when you will make a mistake. Okay, and this is, I think, frequently happen. Okay? Because sometimes if we take from this point and then go forward and then back to the same point, sometimes you will get the result 0 sometimes. When you integrate, it will result in 0. Because you are retracing back to the same positions. Okay. So the better approach for me, my suggestion, you can take half of the measurement. So you can take from here, maybe up until this way, and then multiply by 2. It's safer. It's safer. And you avoid mistake and you avoid something that might happen when you take it full circle. Okay. So we can write the measurement for the arc length. This will be r squared plus dr d theta squared d theta. Okay, and since we are going to approach the theta from 0 to pi and then multiply by 2, let me rewrite this, taking 2 in the front. Okay. So I think we can also check the r d theta, which is 2 sine or negative 2 sine. And then we can put everything inside. So 2 plus 2 cosine theta squared plus negative 2 sine theta squared. And then we try to finish this equations. We try to solve this, and it takes time, it takes patience. 4, 8, right? And then 4 cosine squared theta, and then plus 4 sine squared theta, and this is something we like, right? Because this can be equaling to 4, right? So we could write this 4 it's become 8 plus 8 cosine theta d theta. Okay. Now this is something that we expect from a typical arc length situation. Usually in arc length, you will find in the many questions, we are going to have this square root and then there is some trigonometric equation inside. Remember what should we expect? What should we do? We expect the inside is having a square. So we need to make sure that this going to transform into the squared form, and then we can cancel with the square root. That is if you want to compute using algebraically, or if not, put this in your calculator. Sometimes maybe it will be faster, but I think if you get until here, I think you already get mostly correct for this question. So, but I will let you see the algebra if we using the idea for the equations. So remember that the angle or double angle formula. So if we have the cosine 2 theta, this will be 1 plus 2 cosine squared theta, right? So if we have cosine, minus, right? Minus or plus? Minus, right? Minus, right? No need. I think I will just prove this myself. So it should be cosine squared minus 1. Okay. Yeah, that's why I feel weird. Should be this. Okay. Okay. So if we have cosine theta, we can also write the similar situation and with this half angle formulations, right? Which means cosine theta, okay. Which means that if we have the 8 plus 8 cosine theta, or maybe let me finish off this to make it clear. This will be 1 plus cosine theta. Maybe this will be erased first. Okay, I will multiply by 8. This will be 8 plus 8 cos theta. 16 cosine squared half theta. Okay, let's do this. So we have here 16 cosine squared and half theta d theta. Now this is something we like. We can take the square root, make 16 become 4. So 4 cosine cosine half theta, right? Okay, I think it's clear. And then finally we integrate. So integrate is become 4 sine half theta, and we need to divide with half, right? We evaluate from 0 to pi. So we only take the pi because 0 will be 0. So pi over 2 is 1. So 4 divided by half will be 8. 8 by 2 will be 16. Can you check if using calculator gives you 16? Can you check this from here? Can you check your calculator? What the number it gave you? Okay. Anyone using calculator? Can we check? I believe myself. I just want to know the calculator. I'm curious. I'm confident this is true, but I want to know his works. Okay, I think. Okay. Okay, now back to the questions here. Which one we need to discuss? Any request? All? Yeah, I know we need to take all, but we need to take priority which one. I will give you the notes later, okay? After we finish. Anyone? Which one? Probably 1 to 6. We have 4. We done 4. 5 or 6. 5 or 6. When do you want to try 5? Okay, maybe 5. It's interesting. Interesting. Yeah, it's quite. Actually, it's quite. Okay, let's try 5. So we have 2 different series. Okay. So let's try this is 4. So here is 5. So first we have the series. That's the first one. And we have the second one. Okay. Now how to take the first one? Any idea? It is having the ln. Well, this can be answered by if we could make it into a logical statement. Yeah, limit comparison. Who says that? It's true. Limit comparison test. Who says that? But that's true. Yeah, that's true. We can take limit comparison test. So basically, we get the 1 plus 1 over square root of n, right? So if we take the an as this ln, and suppose that we have some other known series, which is, I think, to make it works, we need to choose 1 over square root of n to be compared with. Okay. Why? Because we are expecting, if we try limit comparison test, we are going to test the limit by taking a and bn as ratio, right? So we are expecting, by taking some method in limit, we're expecting that these two will somehow can be solved. Okay. Yeah, it will be different. It will be different. So this could be written as limit as n getting larger of the ln 1 plus and if you see this limit, this kind of limit, we are going to take back to the calculus 1 in limit, which if you take the infinity inside the equations, this will be giving you 0 over 0 situations, right? Okay, so which means that this is 0 and 0. Then our savior L'Hopital rule will be helping us. So we take the L'Hopital rule. I think it's easy. Okay. So we take that as limit. This will be 1 over. It seems really big equations, but I think we can solve it. And this will be negative half and negative 3 over 2, right? Half. Okay, but negative half, negative 1, so negative 3 over 2, right? Okay, correct. And then over, we derive the bottom equations the same with that, which we expect this to be cancelled, right? So we can cancel this with that. Okay. And then take the limit. It's going to be equal to 1, which is a good number. It's a positive number. And which means that since the limit or the sum of the series for 1 over square root of n, this will be diverges because of the P series. Then the series for the ln 1 plus 1 square root of n also diverge. Okay, so that's number 5A. Since it is ln, I don't think other methods will work. Okay, I think we can use the limit conversion test. Okay, so this is using, let me write the notes here. Use limit comparison test. Okay, now the second part of the questions. We have a fractions that is having a combination of power, right? So it means my suggestions, whenever you have this kind of questions, they have like power like this, okay? And this is alternating. Either take the alternate series, or we could directly use the ratio test. Because ratio test, we are going to take the absolute value. So when it's a convert, it will converge absolutely. So use the ratio test. So this will be so an plus 1 will be n plus 2. 3 with power of n plus 1, and then be careful, this should be written as 2n plus 1 plus 1, okay? And then multiply the 2n plus 1 This will be n plus 1, and then 3 to the power of n. And I think we can cancel this, so this will be 3. This will be 2 to n plus 3, right? And we can cancel that out with this. So this is 2, this is 2. So we have 8 and 2, and we can also cancel that. So we can cancel this 2. So we have 2 with power of 2. So now we have n plus 2 over n plus 1 multiplied with 3 over 4.
You put the 1 not in the right place.
Hmm?
You put the 1 not always. No.
True, right? 2, because it's 2 and 8, I cancel 2 and 8, so it's become 4. So 2, 8, right? So taking limit, increase as it increasing, this will be equal to 3 over 4, which is less than 1, which is by ratio test, since this is less than 1, this will be converged, right? Since it is less than 1, then the series is, we can directly say, absolutely convergent. Okay, maybe one more question. Okay. Okay, let's move to 7 to 9. Which one? Which one do you think that need to be discussed as your priority? 9? 9? If you know how it is, it will be not too difficult actually. 7, 8. Maybe start just from 7, okay? Start from 7. If we have time, we can go for 8. If we don't have time, continue on the Thursday class, okay? I think we only have a small time left. Okay, let's start number 7. This is I say this kind of question is like a standard questions in series. So this is part of the power series. Okay, so we need to find the radius and interval of convergence. So every power series, we are going to take the ratio test as the beginning. Okay. So taking the ratio test, this will give you some computations here, which is 2n plus 1, x minus 2n plus 1, n plus 1 plus 2, so n plus 3 factorial, and then n plus 2 factorial, okay, so we can cancel this and that. We'll live with x minus 2. With this 2 with power of n, we can cancel, so we have 2 in the front. And how about the factorials? The factorials, if you remember, if we have n plus 3 factorials, we can write this as the same, right? Okay, so we can cancel this part with this. Okay. So we are left with 2x minus 2 and then 1 over n plus 3, which I will take the limit. Or this is, I will just make sure that this is still in the absolute value first. And the limit will be just equaling equaling 0, right? So since limit is equal 0, then all x will be all satisfy the equations, which means the radius r will be all x, and interval will be also possible for all interval of x. Okay. So this is number 7. Okay. Power series. Okay, next is number 8. Number 8, if you see the question, let me just see the question here. So we have a functions x sine x squared. Okay. So this is the function. We need to find this f derivative 203 times derivative with x equals 0. Okay. And we need to find that the coefficient, right? The coefficient, part of the coefficient in the Maclaurin series. And I give you a hint. You can start with a function f of x sine x, which means that we are expecting to know the Maclaurin series for sine x. And then we just need to substitute x with x squared and then multiply with x to make a new summation, the new series. Okay. So what is that? So let me write here. So f of x is x sine x squared, right? So we start with the f of x equals sine x. Or let me just, maybe it's not f of x, it's confusing. Let me start with sine x. Okay. In the Maclaurin series, this will be equal to the sum. The sign will be the odd value, right? The odd value with factorials. And it will be alternating. Okay, that is our Maclaurin series. Now to make it sine x squared, we can exchange all x with the x squared. or this will be that will be our new series for the sine x squared. And then we need to just multiply with x, sine x squared, which means taking the sum, or maybe let me write in a new way. So this will be sum x with power 4n plus 3. Okay, that is because of the x. Okay. Now this is the series that we are going to observe. Okay. Now remember in Maclaurin, the general form or the general formula is going to be the f of x is f with the n derivatives at x equals 0 over n factorial multiplied with the x with power of n. Now, at n equal 203, these formulations become, let me just write here, this will give you 203 of 0, 203 factorial, and x with power of 203. And then since the 4n plus 3, we need to make it equal to 203. I hope you get my idea because I'm using the same n. How about I'm making into different n to make it distinguishable? Okay, so let's make this. The original formula is n, but I will write as k. Okay, as k. Okay, I hope you understand what I mean by this, because you will see some redundant of n and you will maybe confuse which part of n is that. Okay, now n, I will refer n as our formulation here, and k is the original formula. Okay, so I will make this 4n plus 3 is equal to 203. Okay, so n, we get n is 50. So when n is 50, I will get the f 203 and at x equals 0, right? So based on the Maclaurin formulations, so back to the Maclaurin formula, we take n equal 50, that is going to be equal 203, like that, and then this will be equaling 101 because it's 50, so we put 50 to here, so 50 plus 1 is 101, right? So this will be 101 factorial. So this will be, since negative 1 with power of 50, it's even number, so it will be a positive. So this will be, let me write with different color. Okay, so this is the coefficient that we want. Okay. So this is coefficient of x203. Or we can write coefficient of x with power of 203 is 1 over 101 factorial. Oh, and the question, what is the question? The coefficient or what? I forgot the questions. Oh, the F203 of 0. So this is the question. Okay, not the coefficient. Sorry. So not the end of the question. So the question is this. So we need to write completely. So this will be since this is the whole formula, this will be equal to, supposed to be equal to, so these equations equal to this 1 over 101 factorial. Let me write x203 101 factorial. Then the F203 of 0, this will be, we cross multiply, this will be equal to 203 factorial over 101 factorial. Okay. Now this will be the answer. Right? If we put back to the equation, if we put back here, it will give you this one factor. Okay, so that's correct. Okay, yeah, so the answer should be solving the F203 of 0. Okay. But if the question asking the coefficient, this will be the answer. If the question asking coefficient. Okay. Any questions? But I think time is up. So